In this video, we're going to begin our conversation about commercial ice machines. Now, ice machines is a really separate area of refrigeration. Every refrigeration tech does not understand and do a lot with ice machines, and every tech that does a lot with ice machines does not necessarily do a lot with commercial refrigeration. Okay, so the best technicians understand all three areas of refrigeration: your comfort cooling, your process and food refrigeration, as well as the ice machines. So we're going to be talking about packaged ice equipment here. Packaged commercial ice machines are the ones you find in restaurants and hotels. Packaged ice machines are a single unit. There's other ice machine types used in residential or block ice houses, but we're not going to be talking about those as a part of these presentations. Most machines have a four-step cycle: flush, fill, freeze, and harvest. The flush cycle flushes water from the reservoir and replaces it with fresh water from the tap. This provides basic cleaning and removes minerals that are left over from the freeze cycle. This is usually the first cycle when you turn the machine on. The fill cycle also occurs during the flush cycle and brings the water level to the right place for the next freeze cycle. The fill cycle ends via a time or a float switch. The freeze cycle is the cooling cycle. This is when the compressor is running, creating a cold evaporator coil and creating ice. The pump also circulates water during the freeze cycle. The freeze cycle is terminated by time or by the thickness of ice on the evaporator plates. The harvest cycle is the last part of the cycle. The harvest cycle is where the compressor goes into hot gas defrost and breaks the ice loose from the evaporator coil. Ice is then flushed off the coil by water that is circulating and is strained out into the bin. The water continues to circulate. The cycle is terminated by temperature, pressure, or time. Once the harvest cycle ends, the sequence starts all over. Very important notes. Ice machines do not have a defrost cycle. It is the harvest cycle. Ice machines do not have a cooling cycle. It is the freeze cycle. So you do have to understand these two differences from regular refrigeration. Defrost, yes, we're breaking ice off the evaporator, but we want that ice. So it is the product we are harvesting. We don't have a cooling cycle because we're not cooling anything. We are actually freezing something. So the components of an ice machine are similar to that of basic commercial refrigeration units. The compressor and the condenser will be the same. The hot gas solenoid and the TXV are the same. What is different are some of the components like the evaporator and the sequence of operation. So a few additional components we have. We have a bin control. It's a mechanical or solid state sensor that senses the level of ice in the bin. Sometimes uses a pressure sensitive arm, sometimes uses an infrared beam, sometimes uses a thermostat that senses the ice level. The main purpose is to stop production of ice when the bin is full. When the bin control fails, what you will find is ice built up that continues to build up into the evaporator, not allowing fresh ice to drop down. And it looks like a giant iceberg. You also have a water solenoid. This solenoid allows fresh water to enter the system when the sequence calls for it. This is a solenoid valve that is on the fill line. That's the water line coming in from the tap water or from the water supply piping. Should have a filter someplace in it as well. You have a drain or waste solenoid. It allows water to drain out of the system during the purge or waste cycle. You'll have a circulating pump. The circulating pump circulates water across the evaporator to make the ice. It circulates water across the ice during the harvest cycle, and it pumps water out in the waste cycle. Nothing in this machine works without that circulating pump. There's a float. It senses the water level in the reservoir. It will shut the machine down in a low water situation. It will shut off the fill sequence and signal for the start of the freeze cycle. It sometimes senses the time to begin the harvest cycle. As the water freezes on the evaporator plates, the water level in the reservoir will continue to drop. And once it's dropped far enough, we know that there's ice on that bin, on that evaporator plate that we have to harvest. We have a spray bar. It takes the water from the pump and distributes it across the evaporator for even water flow. We have a thickness sensor. It senses the ice thickness on the evaporator coil. It signals for the start of the harvest cycle. We'll usually have a control board or a control panel. The board or panel is a mechanical or solid-state part that controls the entire operation of the machine. The panel is not repairable. If it's bad, it must be replaced. Controls on the ice machine are either DC, direct current, or line voltage. Make sure you know which you are working with when you service a machine. The evaporator is a little bit different than what we see in regular refrigeration. The evaporator is a solid or formed plate for ice to form on. Water runs across the plate from top to bottom by gravity and freezes in the forms. A thickness sensor senses when the ice is thick enough to harvest. The evaporator is usually kept in between 10 and 20 degrees Fahrenheit. The incoming water temperature determines the productivity of the ice machine. The warmer the water temperature, the less cycles it will be able to make, the less ice is made. The evaporator is coated with a nickel plating. Make sure you do not use harsh chemicals to clean it. You can only use nickel-safe ice machine cleaner. Evaporators can be mounted at an angle or vertically in the machine. Vertically mounted evaporators allow greater capacity because you can have more than a single vertical evaporator in a machine. They're sandwiched together. So the electrical sequence, and there is a Manitowoc G400 handout that I'll link into this, will have a sequence of operation. The main points are bin switch is open and all other components are off. So the freeze cycle begins. The unit is making ice. The toggle switch is in the freeze or ice position. The bin switch is closed. High pressure is closed. Liquid line is open and energized. Low pressure cutout is energized. Compressor relay is closed. The compressor's on. The remote fan motor is on. This could be the condenser fan motor. Harvest pressure is closed. Primary transformer is energized. Ice sensor relay is open. And the water pump is turned off at first and then turned on after a pre-chill. In other words, what happens in this machine is the water does not circulate across the evaporator until that evaporator has cooled to a certain temperature. Once we have enough ice on the machine, on the evaporator, okay, the bin switch is closed, the hot gas solenoid opens and becomes energized. The dump solenoid is open. The harvest cycle ends when the harvest pressure switch opens or time expires. What we're doing in the harvest cycle is we're throwing hot gas across through the evaporator, which heats up the evaporator. In normal refrigeration, where we have a defrost cycle, this would be melting the ice off the evaporator coil. In this case, what we want to do is we want the ice to fall off the evaporator coil, and that's what the nickel-plated coating is for, and fall into the bin. And then we can begin our next cycle. So when we look at maintenance of an ice machine, per health department guidelines in most states, ice makers must be cleaned at least 4 times per year. And the place where the ice maker has to have documentation to show it's been done. Remember, ice is a food. Your goal is to have this machine produce clean, uncontaminated ice that people can consume safely. Step 1, make sure the customer has taken as much ice out of the ice machine as they will need until the machine recovers. Then you dump all remaining ice in the bin. Completely empty the unit. This is critical, not only so you can clean the bin, but so that there's no chance of the customer using the ice in a food process or in a drink mixing setting with chemicals in it. Step 2, follow the manufacturer's directions for washing the unit. This procedure normally requires a couple ounces of nickel-safe cleaner and the wash-rinse cycles on the controls. Most ice machines come up with a control setting that is a wash setting, and it will actually cycle this through almost automatically on the water side. Then what you're going to do is you're going to rinse the unit thoroughly. Again, follow manufacturer's directions. Some people are extremely allergic to chemicals, so you cannot leave any trace of soap or chemicals behind that could be mixed with the ice. Disassemble the entire unit. Consult the manufacturer's instructions for proper disassembly. During disassembly, take great care to keep track of all loose small parts such as screws, little bolts, little plastic pieces that can be easily lost in a commercial setting. Remember, around ice machines, a lot of times there's a floor drain. I can promise you that the little piece you drop by accident will go down that floor drain. Step 5, wash and rinse all parts. Hey, most restaurants have something that's great in doing this. Throw it through the dishwasher. Sanitize. Bleach and water works well. All portions of the machine and the bin that comes into contact with ice. Bleach has a lot of chlorine in it. It is one of the best sanitizers. However, rinse it with clean water afterwards. Never ever use dirty rags during this cleanup process. Always use clean, laundered rags. Step 6, reassemble the machine. The reassembly procedure is usually a direct reversal of how you took it apart. If reassembly is done correctly, you will not have any leftover parts. Test the machine. Okay, you must stay on time on site for a minimum of 2 cycles. If you make any adjustments, you must stay for another cycle after the adjustment. Okay, 2 cycles can sometimes take up to 20-30 minutes per cycle. Take the time and stay and watch it. Wipe down the outside of the machine and make it look clean. Oh, in this step, throw the ice away that is done in the first 2 cycles. That's why you have to stay for 2 cycles. You have to dispose of that ice. It could be contaminated. Okay, so once you've wiped down the outside of the unit, you make it look clean. Remember, appearance is the first thing that people notice in a restaurant or any place that deals with food. The shinier, the better. Things to watch out for during service visits. A clogged water filter will reduce the thickness of the ice that is being produced. High incoming water temperature. This will increase the freeze time and sometimes reduce the thickness of ice. If you have any doubts, follow the piping back and figure out where it comes from. I have seen somebody install an ice machine using a hot water line by accident. If a machine has a thickness sensor, make sure it doesn't move. The thickness sensor needs to be stationary. If it moves, it's going to be pushed out by the ice or the water. So ice machines, again, they're refrigeration units, but because of the different components and because it produces food, ice is a food, you have to be very cautious of the operation and the cleanliness and how you handle the equipment. We will go further into ice machines and how they work in the next presentation.